Alright, so in this video we're continuing with section 7, chapter 2.5, the chain rule. So we're just going to do a few more examples. So remember with the formula for the chain rule. The formula for the chain rule, we start off with a composition. So we're differentiating f of g of x, right? And so the chain rule says, take the derivative of the outside function and then evaluate at the inside and then multiply by the derivative of the inside. Okay. So what would we do with something like, how about the cosine of h of x? I'm going to call that w of x. What would w prime of x be? Right, so the cosine is my outside function, so therefore I would differentiate that first and leave space for your inside function. Now just put in your inside function, right? That's what we have here, and then multiply by the derivative of the inside function, so the whole thing is multiplied by h prime. Good. Similarly, how about if w of x was something like e to the f of x power? Then w prime of x, right, would be your e to the f of x power times f prime of x. Good. So in particular, right, you might say, oh well, how about if w of x is equal to e to the sine of x? Right, then w prime would be e, right, that's my outside function, the derivative of the outside function. Then I evaluate at the inside function and multiply by the derivative of the inside function. Okay, and now let me pause and get another example ready for you. Alright, so continuing, here's an example from the first exercise actually. And so let's see if we can differentiate this. So you'll notice that overall we have a product of two things, right? And so when we differentiate this, we'll use the product rule first. And so we'll take the derivative of the first function times the second plus the first function times the derivative of the second. I'll go ahead and just write it as with a prime notation first. Okay, so I haven't actually differentiated anything yet, right? I just applied the product rule. But now we will actually compute these derivatives, so we could even compute them off to the side. So how would you compute the derivative of e to the 5x? And this is where we have the composition, right? So that's like that e to the f of x we had before, right? When we had e to the f of x, our derivative was e to the f of x times f prime. So similarly here, this derivative is e to some power, and that power is 5x. Then you multiply by the derivative of the outside, which is 5. Good. Then the other derivative is also, let's go ahead and write that over on this side. So that's just going to be 2x plus 7 to the x natural log of 7. Good. And now we substitute these into our expression up here, right? And so f prime of x is going to be the derivative of the first function. I'll go ahead and write the 5 in the front. That's more natural, I think. And then times our x squared plus 7 to the x power plus e to the 5x. And now I've gotten my full derivative down here, times 2x plus 7 to the x natural log of 7. Good. So there's the answer to exercise 1. Alright, so here's another exercise. So v of t is t to the sixth power times e to the ct, where c is assumed to be constant. Good. Let's compute v prime then. So the big picture here is that you have another product, right, between those two functions. And so the big rule that we're going to be using is the product rule. And so we'll just go ahead and write the product rule out first, and then we'll fill in the details like we did the last time. So I'm going to take the derivative of the first function times the second function plus the first function times the derivative of the second function. I don't know why I put that in parentheses. Good. And now we just go through and compute our derivatives, right? So the derivative of t to the sixth is 6t to the fifth, and then the derivative of e to the ct. Remember, that's a function, so the derivative of c times t is just c, and so we end up with just c times e to the ct. Good, using the chain rule. So this one was the power rule. And so now just plug those in, and v prime of t is 6t to the fifth e to the ct plus t to the sixth times c e to the ct. Perfect. Good. I'll pause here and we'll come up with another example. Alright, so let's try this one. So we see that this is a composition, right? This e to the minus 5t squared plus 9 is the inside function, and then the square root is our outside function. And so when we differentiate then, we might go ahead and rewrite that square root, right? That's going to be e to the minus 5t squared plus 9 to the 1/2 power. Good. So y prime is going to be 1/2 times something to the minus 1/2, right? So that's, this part is the derivative of that square root function, right? And so now we just put in the inside function, leave that alone, e to the minus 5t squared plus 9, and then we multiply by the derivative of that, right? So the derivative of the plus 9 is just going to be 0, so we're just going to be really just differentiating e to the minus 5t squared. And so I could even write it that way and not even evaluate the derivative yet. And then down here I might ask, well, how would I actually do that? Oops, I'm going to run out of space. So that itself is a composition, right? So the derivative of that is e to some power times the derivative of minus 5t squared. And so that would be minus 10t, minus 5t squared. Good. And so this whole thing then, the derivative will become 1/2 times e to the minus 5t squared plus 9, that's our g of t, to the minus 1/2, times this derivative, which ended up being this. I'm going to run out of space. Sorry about that. I'll just write it down here. Minus 5t squared, right, times minus 10t. Good. All right. So let me pause again and we'll try one more example. All right, so here's another function. And again, kind of the big picture is that we're looking at a product of two functions, right? 2x times sine of 6x, and then the sine of 6x is our function composition, right? Because the 6x is the inside function, the sine is the outside function. So when we go to differentiate this, right, take the derivative of your first function times your second plus the first function times the derivative of the second. Okay, and then the derivative of 2x is just 2, right? And then the derivative of sine of 6x. Now we're using the quotient, or sorry, not the quotient rule. What is the rule we're using? The chain rule. So the derivative of sine is cosine. Our inside function is 6x. And then multiply by the derivative of your inside function, which gives you the 6. Good. So then you can write down the full thing now. That was 2 sine of 6x plus 2x, and then it's going to be times 6. So you could actually put the 6 with the 2, right? And then make that 6 times 2, which is 12. And then it would be cosine of 6x. Good. That just simplified things a little bit. All right. So I think we may try one more example. Okay, these are coming from exercise 9 in the section. I've modified them a little bit. Most of them are, that's f of x up here. It's hard to read. Good. And so we want to differentiate each of these. You might notice that some of these have a generic function in them. So let's see how this is going to work. So f of x is my inside function, e to the x is my outside function, and so when I differentiate, I keep e to some power, and then I multiply by the derivative of the inside. So I put the inside function in, and multiply by the derivative of the inside function. Good. B is very similar, except now e to the x is your inside, and f is your outside, right? So therefore q prime of x would be f prime with e to the x stuck in there, and then you multiply by e to the x. Good. Part C. G of x is inside, the square function is the outside, so when I take the derivative, it's going to be 2 times something to the 1 power, right? That's the derivative of the square, the outside function. And so g of x is just put inside there, times g prime of x. Good. And then the last one is g of x of to the fourth. X to the fourth is your inside function. So now we say a prime of x is g prime. That's your outside function. Leave room for your inside function. Then just put in your inside function, x to the fourth. And then multiply that times the derivative of your inside function, which is 4x cubed. Good. And so again, this is just applying the chain rule over and over again. Good. That's probably enough examples for now. Try the other examples from the exercise section.